Today on All Sci-Fi, what if we're diving into a question that's fascinated humanity since we first looked up at the stars? What if humans created a faster-than-light drive? Buckle up, because we're about to take a wild ride through space, time, and the very fabric of the universe. For centuries, we've dreamed of exploring the vast reaches of space. But there's always been one major roadblock: the speed of light. At 299,792,458 meters per second, it's the universal speed limit. Even at that breakneck pace, it would take us over 4 years to reach our nearest stellar neighbor, Proxima Centauri. But what if we could break that barrier? What if we could travel faster than light itself? Now, let's get into the nitty-gritty of how an FTL drive might work. We're going to explore 3 theoretical concepts that could make FTL travel possible. First up, we have the warp drive, made famous by Star Trek. The idea is simple in concept but mind-boggling in execution. Instead of moving through space, you move space itself. Imagine space as a fabric. A warp drive would compress the space in front of the ship and expand the space behind it, creating a wave that the ship rides like a cosmic surfer. The ship itself never breaks the speed of light, but the warped space allows it to cover vast distances in the blink of an eye. Next, we have wormholes. These are theoretical tunnels through space-time that could connect 2 distant points in the universe. Think of it like folding a piece of paper and poking a hole through both layers. You've created a shortcut. The challenge? Keeping these cosmic shortcuts open and stable enough for a ship to pass through. Our final contender is the most mind-bending of all quantum entanglement drives. This concept relies on the spooky action at a distance that Einstein once described. Imagine 2 particles that are quantum entangled. No matter how far apart they are, changes to one instantly affect the other. If we could harness this phenomenon for transportation, well, the possibilities are endless. Now, before you start packing your bags for Alpha Centauri, we need to talk about the elephant in the room, or should I say the black hole in the spaceship. Creating an FTL drive comes with some serious challenges. First up, energy. The amount of energy required to bend space, create wormholes, or manipulate quantum entanglement on a macroscopic scale is astronomical. We're talking about energy levels that make our most powerful nuclear reactors look like AA batteries. To put it in perspective, some calculations suggest we'd need the energy equivalent of the entire mass of Jupiter just to power up our engines. Talk about a fuel efficiency nightmare. Next on our list of headaches is exotic matter. Many FTL theories require something called negative energy, or matter with negative mass. The problem? We've never observed this stuff in nature, and we have no idea how to create it in the lab. Imagine trying to build a car when one of the key components only exists in theory. That's the challenge our FTL engineers would face. But wait, it gets weirder. If we could travel faster than light, we might inadvertently create time machines. And while that sounds cool, it opens up a can of worms that would make even the most hardened physicist's head spin. Imagine arriving at your destination before you left Earth. You could, in theory, send messages to your past self. Hello, grandfather paradox. The fabric of causality itself could unravel faster than you can say flux capacitor. But let's say we overcame all these challenges. What would FTL travel mean for humanity? First and foremost, the stars would finally be within our reach. We could explore distant planets, witness the birth of stars, and maybe even reach other galaxies. Our understanding of the universe would expand exponentially. We'd be able to study cosmic phenomena up close, potentially revolutionizing fields like astrophysics and cosmology. With FTL travel, the dream of colonizing other worlds becomes a real possibility. We could spread out across the galaxy, ensuring the long-term survival of our species. Imagine stepping out onto the surface of a planet orbiting Betelgeuse or setting up a research station in the Andromeda Galaxy. The possibilities are as endless as space itself. FTL travel would also revolutionize communication and trade. Imagine real-time conversations with colonies light years away, or shipping goods across the galaxy in days instead of millennia. We could create a galactic internet, exchanging information, culture, and maybe even memes across vast distances. But with great power comes great responsibility. FTL travel would force us to grapple with some serious ethical questions. 1. Prime directive. Should we interfere with less advanced civilizations we might encounter? Do we have an obligation to help, or a duty to let them develop on their own? 2. Resource exploitation. With access to countless new worlds, How do we ensure we don't repeat the mistakes of our past and exploit these new frontiers? 3. Galactic colonialism. As we spread across the stars, how do we avoid becoming galactic colonizers, imposing our will on other species or ecosystems? As we've seen, the creation of an FTL drive would be nothing short of revolutionary. It would challenge our understanding of physics, reshape our society, and open up the universe in ways we can barely imagine. But perhaps the most exciting thing about FTL travel is not the destination, but the journey. The process of creating such a drive would push the boundaries of human knowledge and ingenuity, leading to countless discoveries and innovations along the way. And who knows, maybe one day we'll look back on this video from the observation deck of an FTL starship, laughing at how quaint our speculations were. But wait, there's one more twist in our tale. Imagine this: after years of development, we finally create our FTL drive. We set our sights on a distant Earth-like planet and make the jump. The journey is successful, and we arrive in orbit around this new world, hearts pounding with excitement. But as we prepare to make our historic landing, our sensors pick up something unexpected: artificial structures, radio signals, unmistakable signs of intelligent life. We've done it. We've reached the stars, but it turns out we're not the first ones here. What happens next? Well, that's a story for another What If. Thanks for joining me on this interstellar journey. If you enjoyed this cosmic thought experiment, don't forget to like, subscribe, and hit that notification bell. Share your thoughts in the comments. Until next time, keep looking to the stars and remember, in the vastness of space, the greatest frontier is still the human imagination.